I guess probably before we do this, we should review, right? Do you remember the relationship in a 45, 45, 90 triangle from yesterday? It's always the same. That one. Okay, let's quickly review how we got it. So we just decided this is just we made the legs 1, a length of 1, because then we have this scale factor for the hypotenuse that works for everything, okay? That's why these 1s were here. So we have 1 squared plus 1 squared, which is 2. To get c, or this hypotenuse by itself, we needed to get square root of 2. Like square root it to do that. Which told us this relationship is true for every 45, 45, 90 triangle. The long side, the hypotenuse, is always square root of 2 times bigger. Guys, put in your calculator what square root of 2 is, just so you have a little feel for that. So 1.41 times. Okay? Process what that means. It means the hypotenuse is roughly 1.5 times the length, the leg length, right? Roughly 1.5 times. It's just a little bit less. So if we have this 45, 45, and we know that this is 10, this is roughly 1.5 times that, which is, what's 1.5 times 10? Roughly. 15, right? Like 1.5. 110 plus 1/2 of 10. Okay? It also tells us the other direction. If I tell you this is 15, it tells us that this has to be shorter by roughly 1.5 times. 1.5 times shorter. Or roughly 2/3, so this would be 10. Okay? Always, for every 45, 45, 90 triangle, that will always be true. So we wrote down this so that we could use it to get the hypotenuse, multiply the leg by root 2. That would be if you're given a leg, right? To get the leg, divide the hypotenuse by root 2. That would be if you're given the hypotenuse. Okay? And we have this little map. So which of those two versions is this problem? Are we given the leg or given the hypotenuse? We're given the hypotenuse, right? And we want both legs. So, looking at your map or the text description, how do we go from hypotenuse back down to leg? Read it, please. Get your notes out and read it. And until you have this memorized, have that in front of you. How do we go from hypotenuse back down to leg? No, read it again. We're given the hypotenuse. Divide by root 2. So what is the hypotenuse?
14.
So we're taking 14 divided by root 2. It looks like this. Okay? That's it. I don't care if you write a decimal. That's good enough, like that, for most cases. Like, if I said go measure this, then you would want to make it a decimal, right? But that's good enough for this problem. What about this side? Those are congruent, right? Because it's an isosceles triangle, that means the two legs are the same length. So 14 over root 2. That's all. It's nice, right? Because you didn't have to do a calculation. You just be like, hey, that's the hypotenuse. The leg is divided by root 2. Okay? Let's try another couple. Again, you're going to have some time to practice. Just go with me that that's a right angle. Oh, I'll try and draw it better. I'm not. Okay, that looks better. Okay, I'm going to probably just use this one and change, and I think after a few reps you'll get the hang of it. Okay? What is this one? Don't raise your hand when you can tell me. Don't shout it out so everybody can think. I'm giving you this. I want to know that. Yeah, but next time raise your hand. But yeah, it's just 5 root 2, right? Leg times root 2. We don't need a decimal. What would it be though if you did? Yeah, it's like just over 7 and a half. Like just under 7 and a half, right? Root 2 is 1 and a half times. What's this side? As? It's 45, 45. I guess I should have put that in there. I mean, it was implied, but I should write that in there for sure. Okay, let's try it again. What's this side? Don't shout it this time. Just think about it. Okay, what is it? 11 what? It's not divided. 11 times root 2. Why is it times? We're given the leg, finding the hypotenuse, right? Right? This side. What is it? Go ahead. This side? Go ahead, Solana. Okay. So did the decimal matter? The decimal leg size? No. Okay. Don't shout this out. I want this leg down here. What are we given? Like the name of the length? Which one is that? That's the hypotenuse, and I'm asking for a leg. So what is this leg? Everybody? It's just 10. Why? Yeah, it's basically this, right? 10 root 2, the hypotenuse, divided by root 2. What happens to those two things? They just cancel, okay? So this is 10. Let me leave that for a second. How long is this side? Also 10. Good? 12. How long is this side? Don't shout it out. Okay, what are we given? Hypotenuse. We want the leg. How do we go from hypotenuse to leg? What was it? No. Hypotenuse. Okay. Maybe it's the wording. I'm not understanding why this is difficult. To get the leg. To get the leg. Divide the hypotenuse. Well, it's probably because you don't know what the hypotenuse is, so put that on here. Right? The hypotenuse is always where? No, it has nothing to do with bottom or side. Across from the 90, right? Because what if it's like this? That's our right angle. This is our hypotenuse, right? What if it's like... Where's the hypotenuse? Now it's the top, what we would call the top. Okay? So it's always across from the 90. Alright, well maybe that's helping. You gotta know where the hypotenuse is, right? It's always opposite, like reach across the triangle to touch the hypotenuse from the 90, from the given 90. Do we need to reword this, do you feel like? Do you want to shorten it and just say something like hypotenuse to leg divide by root 2? Like, Would that help?
So I was confused how it was saying like to get the, so instead of that I just wrote if given the. Like if you were
Okay,
already
you want to
given-
change that maybe?
and
And say if given first? Because I want this to be helpful to you, because it really is very simple to apply, but if what I wrote doesn't make that clear, then we need to fix it for sure. So here's what Dolly just proposed this. If given the hypotenuse, divide by to get the leg. Is that kind of how you did it? Is that better? Yes for you. Yes for you too. All right, let's change it then. The picture is still fine. I'll just change one at a time. So. If we're given a leg, this thing needs to be replaced. Right, multiply by root 2 to get hypotenuse. And I think I'll just do that little word map. Leg times root 2 equals hypotenuse. What about that too? Does that seem helpful? Okay, let's do the other version. Given hypotenuse, what do we do now? Good job. Shall we try that? See if that's helpful. And if not, maybe just talk to me individually about how to reword it, but let's give this a shot. So we're back here. What are we given? What? Hypotenuse, and I want this leg. So what do we do? 12 over root 2. What's this one? Same, right? 12 over root 2. Okay, let's change this slightly. I'm just making up numbers. 13 root 3. What is this side? What are you given? Ask that first. What are you given? And I want the leg, so what do we do? Done. There's nothing we can do. Well, I don't want to say nothing. We wrote in the note before, I just erased it, but it said, and then rationalize. I'm not sure I'm going to show you that or not, but basically it's a way of getting this square root out of the denominator. And it's purely a mathematical preference. It's not a requirement. In terms of function, like let's say you solved this triangle and this was your answer for this piece of wire or something. You don't need to get that out of the denominator for that application. You just divide and get a decimal, okay? It's a mathematical preference for snobby math people, is honestly what it is. Now, sometimes it is useful. I'll be honest about that. Mathematically, it is useful sometimes. For now, we're going to just put it on hold. Okay? And you guys understand we're still dealing with 45s. I just didn't write it last time. But so this length, raise your hand, or don't raise your hand. Just let me know somehow when you are ready to say this. Okay, good. Okay, you should have got 6. Very good on 6. Okay, here's why. You probably said it was 3 root 2 times root 2, right? That's what you should have said, because this is a leg 2 hypotenuses times root 2, right? Well, what is root 2 times root 2? It's 6, or it's 2. So those are just 2. And then it's just 6, okay? So it's not like always you're going to have a square root, because sometimes it cancels or simplifies, right? Does that kind of help, running through some reps of that? Okay, let's get you some practice. Okay, guys, one thing again, just as always with geometry, is knowing what you're told to know what to do, right? This has nothing on here about is it a special right triangle. All it tells us is just a couple pieces of notation. And so imagine, like, let's say these two are next to each other on a test, right? Or maybe it's like this one is number 1 and this is number 10 or whatever. Okay, same with like number 5. No information telling you which kind of triangle it is. So always try to keep telling yourself, or asking yourself rather, what is this case? So I see it's a right triangle. Well, is it right triangle similarity where we're drawing the 3 triangles? Is it going to be right triangle trig ratios? Is it special? Like, there's a ton of things that you're going to have to sift through for this. So I want you to start developing the habit now of saying, this notation tells me what, and what does that tell me to do? Just like all year, right? We've had that issue, meaning that we've had to be able to do that all year long. So what kind is this? Like, what does the notation tell us about this triangle? Well, it's a right triangle. What do these tell us?
They're corresponding.
No, it doesn't tell us corresponding. Congruent, right? Those arc marks tell us congruent. All right, so what is the measure of each of those? Why? She said 45, if you didn't hear.
It's at 90, 45, 45.
How do we know? Like, why is it even 90, like 45, 45, 90? Why is it that?
Triangles on.
Yeah, right? So you can always go back to that. If we know this is 90, so these two have to add up to 90, and they're the same. So it's really, you could write it all out if you wanted. 180 minus 90, because we know that's 90, and then divided by 2, because there's 2 of the same one, equals 45. So this is a 45, 45, 90. And I realized that I told you which problems to do based on what we had just learned, but understand that you're going to be responsible for figuring that out, right, on an assessment. You're going to be responsible for knowing that that's a 45, 45. I will not tell you. You're going to have to interpret the notation. Okay, are we given, is this 2 a leg or a hypotenuse? That's a leg, so what is this side? This long side. 2 root 2. What is this side? 2. Okay? Alright, number 4. Whoa, that just jumped. This is congruence marks, not a 90. Right? So, what do we know about this whole thing? And maybe we don't care because we have a 90 there. So what kind of triangle are we dealing with? Well, here it is, 90 and two congruent angles, right? Those two have to add up to be 90. They're the same. That makes them 45. But what about this side? What is the measure of this angle right here?
90.
It's 90. Are we sure or are we guessing?
I'm sure, because the other side's 90.
That is a straight line. That's called a linear pair. Do you remember that? And what do linear pairs add up to? 180. So if this is 90, this is also 90. Not guessing, not assuming, it is for sure because of the linear pair postulate. Okay? So what is the measure of this angle? Also 45. It's identical to that other one. And I about wrote 70. Okay. Do you see how two of these add up to what? So this angle is 90. Did you catch that when you did the problem? This whole thing is a right triangle as well. So how long is this whole side? What do we do with this? It's 14 root 2 times root 2, right? Leg times root 2, right? What does this do when you do root 2, root 2? Yeah, so it's just 14 times 2. Okay? How long is this leg?
14.
It's the same, right? Okay, 5. What kind of triangle is it? This is new notation. Well, it's not new to us, but we haven't talked about it on this page yet. What do these things tell you? If the side lengths are the same, what's true about these angles? Yeah, remember that isosceles triangle theorem? Told us that those opposite angles are congruent as well. So what kind of triangle is this? It's isosceles, which makes it 45, 45, 90, which means this is what? This leg, we're given hypotenuse, what is this leg? 10 over root 2. What's this one? Okay, all right, we're going to stop there. If you didn't finish these, do them for tomorrow, please. We'll check the rest.